Hello, this is Jeffrey Fox here. I'm the instructor as always, for the Big Data Open Source Software and Projects course. This particular unit here is on data access patterns and an introduction to using the HPC ABDS software stack. And this is the first of 4 lessons. Unit 2D, this is 2D, 2E, 2F, and 2G, which summarize these layers. We will later on in section 3 of the course go through each item in the layer in more detail. So let's get going. This is just a broad overview, and we're going to do these layers in order. So here we are. So this unit 2D is layers 1 through 6, and we already actually summarized in unit 2A the first part of that. In an even more broad fashion, we summarized layers 1 through 17, and then there are actually 21 layers because some of the layers have parts. So let's get going. Thank you very much. This is Jeffrey Fox starting the summary of the HPC ABDS stack. This reminds you of the 21 layers. And we're going to get to layer 12 in this particular lesson, and we'll just go through from 1 to 12 in order, sometimes joining some of the layers together. Actually, the note is there are actually 14 layers here, because layer 11 is divided into 3 parts. Okay, let's go. We have 2 layers on this slide because then we didn't do these layers in as much detail as some of the others. So layer 1 is the message protocol. So we'll start off with the name of the layer and the actual entries we have in HPC ABDS. And this is going to be difficult to discern. It basically is the layer that allows you to describe the interface between 2 different subsystems communicating by messages. Remember, in any distributed and actually maybe a non-distributed applications, you tend to build services or other units which communicate by messaging, and it's therefore very important to be able to do this messaging and also to do it quickly. And Protobuf from Google and Thrift have a similar functionality. They allow you to build messaging protocols and define data dependent, data syntax dependent, depending on your application interfaces between these components. Avro is a little different. It carries the schema with the messages, so you write in a more general fashion. Layer 2. Here is the first 3 of these units these technologies are roughly the same. They're all, in fact, Google Chubby is the parent of all of these. It was the first deployed system as I'm aware of this type, and Apache Zookeeper coming out of Hadoop then built on that. And these technologies are used to synchronize and coordinate different components of a distributed application. So that's sometimes called concurrency control. And it's always very hard when you have multiple things going on in the distributed fashion to make certain that you have a correct state which is consistent between the different distributed systems. And that's what Chubby, Zookeeper, and a recent research assistant called Giraffe, which extends Zookeeper, do. JGroups is a rather different thing. It actually builds secure messaging between multiple units. Okay, layer 3 and also layer 4 on the same slide. Again, we don't do these. These are the cross-cutting layers, which we didn't spend so much time on in our analysis, because they were roughly in common between HPC and ABDS, and there weren't, apart from a few exceptions, there weren't so many innovations. So security and privacy is certainly incredibly important, and then many people would say it's the dominant problem in cloud computing or big data. And if we, it's broken up into various parts, one of which is authentication, then there's authorization, which once you found out who the person is, you have to find out what he's allowed to do. Often, if you go to the web, you can see you can use your Facebook or your Microsoft or your Google login, and that's sort of an example of federation. One login allows you to log into multiple different places. In Common has that feature. It's run between, it federates the logins among lots of research and higher education institutions, many hundreds of them. And it has identity management, which is authorization and related services. LDAP is a pretty simple but very important technology coming from the internet world, and it's basically a distributed database with key values as the basic unit, and it allows you to record everything you want to know about users, their logins, their passwords, their photos, whatever you need to know for a user profile. And there's a standard for this called X500, which LDAP is a limited implementation of. Keystone is part of OpenStack. We will find that OpenStack has around 16 separate sub-projects, one of which is Keystone, which is building authentication, which we just discussed under In Common, and role-based authorization. So role-based authorization is a two-step approach to authorization. You assign users roles, and you assign roles capabilities. And so once you've decided a user has a role called dictator, you then look at dictator and see what that somebody with the dictator role can do. In this area, we have actually Squirrel, which also occurs also later on, which is comes from a startup company of the same name, which focuses on analyzing big data using Accumulo, which is a NoSQL store, to identify security issues such as cybersecurity incidents where people do denial of service attacks or else linkages between different entities which suggest some sort of funny business going on. Something pretty important, which actually maybe the most Apache doesn't seem to spend quite so much time on. There's one Apache system, Ambari, which is aimed solely at Hadoop, and there are actually also tools built into DevOps frameworks and the application hosting frameworks that do monitoring. The systems, the other systems there, Ganglia, Nagios, and Inca, are monitoring systems coming largely from the cluster computing or HPC community. And they are either system level or user level monitoring. They gather messages, store them, report them, and allow you, for instance, to find the status or something else of systems. All right, we're coming on to layer 5. This is a really important layer because it's basically the lowest infrastructure as a service layer, and we generalize this to include sort of everything from hypervisors, Linux containers, bare metal, anything that defines the core infrastructure in which you're running. There's an area that we actually have missing here, which you could call networking, or software-defined networking, because that doesn't appear to be, at the moment, a major force in this particular stack. It's a major force in the world, but not in this stack at the moment. But the only exception to that we'll see in the DevOps section with a tool from Cisco. So we have a lot of things here. We have the major hypervisors, Zen, KVM, Hyper-V from Microsoft, and VirtualBox, and from Oracle, and we have the alternative virtualization approach through Linux containers brought to people's attention recently through Docker, OpenVZ, LXC, and Linux vServer. Then we have, on top of this, we have at least on top of the hypervisors, we have the virtual machine managers. This was pioneered by actually Eucalyptus, then Nimbus. But then we have these important capabilities. OpenNebula from Europe, it's very, Europe was correctly very proud of that because there's an area where they're actually state-of-the-art. OpenStack is started by NASA and Rackspace, and now the dominant open source manager. And as it mentions here, OpenStack has 16 different sub-projects. We saw one of them, Keystone, under security, but there are many others like Heat and DevOps and things like that. So they just manage the computing, the security, the clustering, multiple VMs, the storage, and the networking of virtual machines. As a bare metal is implicitly defined here, and DevOps layer is how you will actually take whatever's at this layer and sort of build upon it. And we mentioned Docker already. CoreOS is an interesting lightweight version of the operating system, Linux, customized for containers and also in particular Docker. And of course, we have the famous and critical public clouds. Amazon's dominant, but Azure and Google are also very, very important players, and they have their own infrastructure at this layer. And then when we come to DevOps, we'll learn how to move things between these different solutions. Okay, we have layer 6 here, which is the DevOps layer, and it's got a pretty rich set of subsystems here. We won't do Docker again. We note that at IU, we actually take many of these systems here and integrate them together in a system we call Cloud Mesh, which is how we claim to, or we implement software-defined systems in the particular fashion that we know how to support. That involves other subsystems, libcloud, which is in the interoperability section, Cobbler, which we're replacing by OpenStack, ironic, for bare metal, Chef, Docker, Slurm, Ansible, Puppet, and Celery. And Puppet, Chef, Ansible, and SaltStack are all similar systems. They actually are called configuration managers. They allow you to specify the software and features you want on your hardware. Then we have on top of those Juju and OpenStack Heat, which sort of build whole systems, or what we can call virtual clusters, which have multiple different software components. There are many bare metal provisioning systems. You either want to do bare metal to build on it for virtual machines, or you just want bare metal or not virtual machines. And the advantage of this way of thinking about it is you can build hypervisor-based systems or bare metal-based systems with the same technology and the same scripts, and you just change how you provision to go between hypervisor and bare metal. Foreman is a well-known general-purpose system. Boto is impressive. You just see what it does. It's remarkable. It's a Python code, and it allows you to do a general DevOps for the 40 different Amazon public cloud platform features. That contrasts with Amazon's OpsWorks, which is the more basic DevOps, which is actually a more recent system. ROX is famous from the HPC community. It's a cluster deployment system with, like all of these systems, they specify their software configurations in generally different syntaxes. This is called roles. Cisco is a DevOps system from, of course, Cisco, and it, of course, addresses networking probably better than other people. Tupperware is an interesting approach used by Facebook. They don't use virtual machines, or at least not hypervisor-based machines. They use containers for performance reasons. Kubernetes is a very recent DevOps system focused on Docker, and BuildStep and Git Receive are a part of the so-called Doku system, which is an application hosting framework built on top of Docker. So these last few are directly generated by exploiting Docker.